Okay, let's dive into this. We've got 5 main stops on our roadmap today: the software lifecycle, understanding the user, making the blueprint, leaving a documentation trail, and finally, hunting down the bugs. Starting right off with phase 1, the software lifecycle, going from idea to reality. And this brilliantly illustrates that building software isn't just a straight line from start to finish. Developers rely on a structured process to stay organized, and it's actually a continuous cyclical loop. You build, you deploy, maintain, uncover new requirements, and boom, you start the whole cycle all over again. Inside that giant loop, we basically hit 4 familiar phases. First up, investigating and reflecting on the core problem. Then, designing the form and function. After that comes prototyping a rough draft, and finally, testing it out to see if it actually survives contact with the real world. Now, modern teams usually mix 2 different frameworks to actually get the work done. First is iterative development, which is this continuous cycle of building, getting feedback, and refining. It's a lot like rewriting an essay after getting your teacher's notes. On the flip side, you've got incremental development. This is where you build in discrete chunks, totally perfecting one small piece before moving on to the next. Blending these two is how developers balance speed with stability. Moving on to phase 2, understanding the user. What do they actually want? Because honestly, before you write a single line of code, you have to figure out the actual requirements. You can deploy surveys, do interviews, or rely on direct observation. But crucially, you also need to identify your constraints. Knowing your limits up front, like strict data caps or tight time limits, is just as important as knowing what the user is dreaming of. But, the human element is where the magic really happens. Direct observation is incredibly powerful. Seriously, when you watch someone use a program, to see exactly where they get frustrated, you learn more than a survey could ever tell you. People often can't put into words what's wrong with an app, but you can literally see their frustration, and that tells you exactly what needs to be fixed.
All right, phase 3, making the blueprint or designing the solution.
So the crucial point is establishing the program specification, which is essentially the ultimate to-do list dictated by the user's problem. To map this out, developers rely heavily on visual design tools. They brainstorm wild ideas, storyboard exact screen layouts, and use flowcharts to plot the user's movement. It's all about creating a flawless, logical path for the user from point A to point B. Which brings us to phase 4, leaving a documentation trail. This is all about writing for humans. Up until now, we've focused on the app itself. But program documentation is a written description of exactly how your code works and how you built it. It's an essential map left behind for anyone else who has to interact with your architecture after you've moved on to the next project. A huge part of this map are comments, which are notes written straight into the code. The computer completely ignores them, but they are absolute lifesavers. Writing comments is really just doing a massive favor for your future self. Because I guarantee you, if you try to read your own code 6 months from now without comments, you will completely lose your sanity trying to figure out what you were thinking. Another totally non-negotiable part of documentation is acknowledging your sources. If you grab a clever snippet of code from a website or borrow a fix from a friend, you always have to give credit to the original author. It's just a mandatory rule of professional respect in the builder community. And finally, phase 5, hunting down the bugs and fixing the errors. Now, what's really interesting about this slide is how things actually break. Because let's be honest, nobody writes perfect code on the first try. You might hit a logic error, where the app runs fine but confidently does the wrong thing, like saying 2 + 2 is 5. A syntax error means you broke a grammar rule, maybe a missing semicolon, so the code flat out refuses to start. Runtime errors mean it starts up but crashes mid-stride, and overflow errors happen when you hand the computer a number that's just way too massive for its memory. So here is a pro tip for catching those. Use test cases. This is where you feed your program specific inputs, where you already know exactly what the expected output should be. By actively checking these specific scenarios, you can verify with absolute certainty that your program is doing exactly what it's supposed to do. It's for sure your best defense against crashing software. And that wraps up our look at the builder's journey. Making software isn't just mindlessly typing into a dark screen. It's this deeply human, cyclical loop of investigating, designing, refining, and testing. So I'll leave you with this final thought. If you built an amazing app today, rushed through it, and skipped writing down your map, would you even understand your own code 6 months from now? Thanks for joining this explainer, and keep that curiosity alive.